Hello and welcome back to Math 8. This is a video over Unit 3. We're going to be talking about patterns in bivariate data. And we're going to be talking today about Section 1, which is constructing scatterplots. Okay? So what we're going to do is we're going to be able to construct a scatterplot using a table of values. We will be able to analyze a scatterplot. And then what we're going to do is we're going to classify dependent and independent variables. So first, I want to talk about what a scatterplot is, or what bivariate data is. Bivariate data is a data set that compares two variables, okay? And what that means is we would look at something like this, where hours studied and then the result of a test, so the test scores, okay? Now, this is a table, okay, and this is the graph. Now, what we do is we take this data here and we plot these points on the graph to see what the data shows, okay? So this, when we talk about data, we are going to be looking at the relationship between your x values, and let's go in here, and I'm going to call this my x hour studied, and my test score is y, and we show the relationship between these two, and we see if there's some sort of correlation here. All right, and what I would do, okay, in a situation like this is given a table like so, and given the graph, what we try to do is we try to analyze a scatterplot. And what we say is, all right, well, what we're seeing with this data is that the more hours that students study, the higher the test scores, okay? And, it's not necessarily like always true. However, we find out that there is a correlation with that. Typically the more hours you study, the higher the test scores. Okay, it doesn't work for everybody, but the general trend is that. Okay, that you have this positive slope here. Okay, so the purpose of a scatterplot is we want to investigate patterns in data and find relationships. So let's write this down. That from this. The conclusion that we draw, the conclusion is that the more hours a student studies for a test, the test scores will go up. Okay? And that's what we're doing, okay? And so we're finding this general trend here, that's the case, okay? So what we want to do, when we're talking about scatterplots, is talk about the independent versus dependent variables, okay? So in bivariate data variable relationship, the independent variable influences change in the dependent variable, okay? So what I always know is that the independent variable is always x, okay? And the dependent variable is always y. And how I know this is that y depends on x, okay? And we've talked about this before, but that's, what we're doing, all right? So in this scenario, okay, what we want to do is we want to identify what the independent variable is. Independent variable and the dependent variable. Okay, independent variable is your x value, dependent variable is your y value. Now, what they're doing is it's saying students keep track of the number of inches of rainfall each month in their city, okay? And so what we want to do is we want to think about, all right, what is our independent variable? What things can we choose? What thing is going to always be, constant, when talking about, how we can measure the rainfall, okay? And oftentimes what you find out is that the independent variable is time, okay? So time, and in this case it is, and this is time in months. Okay, that's our independent variable. Now what we're doing you know, the time in months, you know, what are we influencing change in? Okay, what would be the dependent variable? And that would be the number of inches of rainfall. Okay, so the dependent variable is the number of inches of rainfall. And what you have to think about is, what depends on what, okay? And the time in months, or is it the number of inches in rainfall? Okay, the inches in rainfall depends on how much time has elapsed, okay? Time does not depend on rainfall, okay? And so that's what we, oftentimes have to look at, okay? Let's take a look at the next one. A cell phone company records the number of texts sent according to a person's age, okay? And so one of the things that we want to take a look at in this situation is identifying our independent variable. So let's go in and write those down at least. So independent variable and our dependent variable. Okay. Now, age, think about this, okay? Remember how in the first example I said oftentimes it's time is our independent variable. And that's the same case here, but what we're going to do is we're going to call this age in years, okay? And then the number of texts sent would be your dependent variable. So the number of texts sent, okay? And let's just take a look at this, and it kind of tells us. A cell phone company records the number of texts sent according to a person's age, okay? And so what you have to do is read that and say, okay, what depends on what, okay? And that's kind of how I do this. And so, I would say that a person's age does not depend on the number of text messages sent, okay? That doesn't make any sense. But the number of text messages sent would depend on a person's age, okay? And we analyze that, okay? So let's go ahead and take a look at the next page. Okay, on this one, we often can use the word input and output of bivariate data. And so what I want you to realize is that input means x value, okay, and that's also your independent variable. Okay, your output is your y value, and that's often called your dependent variable, okay? So let's identify that first, dependent variable, okay? And so what we have here is we want to identify, take this situation, identify our independent variable and our dependent variable. So what we know is that data is collected relating a person's shoe size according to height. So this one is similar to the one we just had. They use that word according, okay? That means that the shoe size is more or less dependent on the height. So our independent variable here that we would put down would be our height, okay? And that would be our x value, okay? Or we could call it our input, all right? So we use these words interchangeably. Independent variable, x, and input. Those all mean the same thing, okay? Then the shoe size, okay, is dependent on the height, okay? So y, and then this would be our output. Okay, so when you have the scenario and you're creating a table, then you want to put in here that the first column is the height, and then the second column is the shoe size, all right? So we've got to be able to take this information, okay, and, identify our variables first and put them in the right spot, and then we can analyze and look at the data. Okay, so let's look at how to create a scatter plot. Okay, and we've kind of looked at a few, but I haven't gone about how we create them. And so, what I want to do here is look at these steps. Okay, label the axes according to the input and output variables. Okay, then we will plot the ordered pair of the independent and dependent variables on the coordinate plane. We will identify if there is a relationship between the variables. And all right, so let's do that. Okay, so based off of this, we have this first column which shows the season, and the second column which shows the viewers. Okay, now the season, that's kind of like a measure of time. All right, season 1, season 2, season 3, season 4, and then the viewers of a certain show. Okay, so here's what I've got. Season, that's going to be our X value. Okay, label of our X-axis. And then viewers in millions is going to be Y. Okay, now over here, what I want to do is I want to label my axes. Okay, so this is going to be the season, and this is going to be the viewers. Okay, and that's how I do that. All right, now what I'm going to do is I'm going to take these points and I'm going to turn them into ordered pairs. So in season 1, we had 21.3 million viewers. Now we're not going to be perfect here, but we're going to be pretty darn close. All right, so that's that point. Okay, this becomes the point 1, comma 21.3. Okay, this one becomes 2, comma 27.6. So let's graph that. So at season 2, all right, we had 27.6, so it's going to be right above here. Okay, in the third season, we have 20.6. So in the third season, our viewership went down. Okay, in the fourth season, got 24.1. All right, so here's the fourth season. And then in the fifth season, we had 26 million viewers. Okay, and the question is, so we've done that. So we've done number 1, where we label the axes according to the input-output. We've plotted the pairs of independent and dependent variables here. Okay, and we want to identify if there is a relationship between the variables. And, what we could say is that as the seasons progress, as the seasons progress, the show gains more viewers. Okay, except for season 3. Okay, then we kind of look at that. So except for season 3. Season 3, apparently that show sucked because you only had 20.6 million viewers. Okay, so except for season 3. Okay, that was low. All right, but all the other ones, they do show a general trend going up. As the seasons progress, you go up. Okay, you go up here and you go down, up and up. So overall, your viewership went up as the seasons went on, except for season 3. Okay, that one apparently was no good. Okay, all right. So now let's do this. We got another one. So data for 7 students' grades are shown by ordered pairs, where X is the student's homework scores. Okay, so that's my X. Okay, homework scores. And Y is their test score. So we're comparing, if their homework scores are good, how are their test scores, And so what we're going to do is we're going to create a scatter plot to determine if there is a relationship between the variables. So what I'm going to do, and it's not going to be perfect, but we're just going to try our best. Let's go ahead and plot this first point. So 75, 71. All right, so I'm going to plot that right about here or so. 72, 70, 64. Okay. 95, 100. Woo. Pretty good. 97, 83. Okay. 85, 78. Okay, 60 and then 50, and then 65, 75. okay? And what we show is that, is there a relationship between these variables? Do they tell us something? Okay, can we draw any conclusions? And the conclusion is that the more homework that the student does, the higher their test scores are going to be, because they have this trend that they're going up like this. So what we'd want to say is our conclusion, all right, is that the more homework that a student does, okay, the better the test score, okay? And this, everyone's different, so it's not always true for everyone. However, I mean, you look at this, okay? You have the person over here, they did 60, they got scores of 60 on their homework, and how that translated was they got a score of 50, versus the student that gets 95% on their homework, typically will do better on the test, okay? And then you have this one here, the student that got a score of 97 on their homework, but didn't do very well on the test. They got an 83. I mean, 83 is still good, but, it's not an exact science. So, but the trend is, okay, by the data says, as the homework scores increase, if you do better on the homework, that is an indication that you will probably do better on your test. Okay, so pretty logical stuff, cause and effect kind of stuff, but we're just looking at data and drawing conclusions. So this is it for the first video. Let's go ahead and get started on your notes quiz and the edgenuity stuff, and we'll see you in a bit. Thanks a lot. Bye.